Glass, how it's made. Have you ever held a glass bottle and wondered, how does something as fragile as this come from something as rough as sand? Every day, we drink from it, look through it, swipe across it. Yet behind glass lies one of the hottest, loudest, and most extreme manufacturing processes on Earth. Today, we're stepping inside mega factories, where temperatures soar hotter than volcanoes. Robotic arms move with surgical precision, and billions of ordinary grains are reborn as flawless sheets and bottles of glass. But here's the twist. Without one hidden ingredient, none of this would be possible. The origins and paradox of glass. Glass wasn't invented, it was discovered. Over 2,000 years ago, ancient Egyptians mixing sand and soda ash near a fire accidentally created the first glass. Imagine their shock, watching glowing sand solidify into a transparent jewel no one had ever seen before. Since then, glass has quietly become the backbone of civilization. Windows that flood our homes with light, bottles that preserve food, even the screens you're watching this video on. But glass is a paradox. It can resist heat, corrosion, and electricity. It can be recycled endlessly without losing quality. Yet at the same time, it's brittle. It doesn't bend, it shatters. So how do factories transform humble sand into something both incredibly strong and incredibly fragile? Mining and preparing the sand. Not just any sand works. Desert dunes are too impure, full of dust and organic matter. Factories need silica sand so pure it can reach 99% silicon dioxide. To get it, giant open-pit mines are blasted with controlled explosives, crushed, shaken, and spun in massive separation systems. High-pressure water jets blast away clinging particles. Spiral separators spin the sand, forcing heavy metals outward and leaving only the light, clean silica. By the time it's bagged and shipped, each ton of sand is so pure it could pass for powdered crystal. Melting sand into glass. Every week, the world's largest glass plant consumes more than 5,000 tons of this refined sand. But melting sand alone would require impossible heat. So two partners join the recipe: sodium carbonate to lower the melting point and calcium carbonate to strengthen the final product. Sometimes, pigments like cobalt oxide add color deep blues, emerald greens, or golden ambers. This mixture rides on endless conveyor belts to the furnace, a roaring gas-powered monster running day and night at 1,650 degrees Celsius. That's hotter than molten lava. Inside, the sand mixture softens, collapses, and finally liquefies. For 24 hours, it bubbles and glows, releasing gases until it becomes perfectly clear molten glass. Technicians in fireproof suits watch closely. If the temperature wavers by even a few degrees, the entire batch could fail. At the bottom of the furnace, glowing streams of liquid glass flow like rivers of lava. And from here, the magic of shaping begins. Shaping bottles, the double blow method. To make bottles, the molten glass is cut into glowing drops called gobs. Each gob weighs just the right amount for a single bottle. The gob drops into a preliminary mold. Compressed air blasts into it, forcing the hot glass outward until it forms a hollow bubble called a parison. Still glowing orange, the parison slides into the final mold just inches away. Another burst of air stretches it into its final shape, whether that's a soda bottle, a food jar, or a medicine vial. This entire process takes only seconds. Yet behind it, thousands of valves and sensors are synchronized to within a thousandth of a second. That precision allows factories to produce hundreds of thousands of bottles a day, each nearly identical. But bottles aren't the only story. For windows, skyscrapers, and smartphones, the process looks completely different. Flat glass. The float process. Flat glass begins with the same molten mix, but instead of molds, it meets a bath of liquid tin. Because glass is lighter, it floats, spreading out into a perfectly even sheet. As it glides forward, carefully controlled cooling zones reduce the temperature step by step. This prevents warping and ensures both surfaces remain perfectly parallel. By the time it leaves the tin bath, the glass is smooth, flawless, and ready for cutting. Diamond-tipped blades, or even lasers, slice it into panels with surgical accuracy. But raw edges are sharp and dangerous, so the panels move through grinding and polishing machines where high-speed wheels smooth every corner into safe, clean lines. And if you've ever wondered how skyscraper windows don't shatter into deadly shards, well, that's where the final tests come in. Recycling and sustainability. One of glass's greatest superpowers is recycling. At flat glass plants, entire hills of broken glass glisten in the sunday. Instead of waste, this scrap is melted back into furnaces. Mixing old glass with new sand not only cuts raw material costs, it lowers the melting temperature, saving huge amounts of energy. In some facilities, recycled content makes up more than half of every new sheet of glass. And because glass never loses quality, the cycle can repeat forever. Quality testing and final journey. Before leaving the factory, every piece of glass faces rigorous testing. High-speed cameras scan bottles for cracks and bubbles. Sensors measure the exact size of each rim. Flat panels are struck and stressed to ensure they don't fail under pressure. When glass passes these tests, robotic arms stack bottles onto pallets or load giant panels onto racks with protective layers between them. From there, trucks and ships carry them to construction sites, stores, or eventually to your hands. Wrap up and engagement. So next time you sip from a bottle, look through a window, or swipe your phone screen, remember, it all began with something as ordinary as sand. Through fire, precision, and ingenuity, those grains were transformed into the invisible material that shapes our world. If this behind-the-scenes journey sparked your curiosity, hit subscribe, because in our next episode, we'll uncover how another everyday material hides an extraordinary secret. I'm the Factory Line, and this is how glass is made.